Now we're going to take everything we've learned about logarithms up to this point, put it together, and use it to solve some very complicated equations involving logarithms. Do you remember? Remember the idea of contracting multiple logs into one log using the properties of logs. Now we'll use a couple of them here. For instance, we're going to take this expression and make it into one logarithm using a couple of the properties. Remember, where am I allowed to put that 2 other than in front? Using the same property, I'm going to place this 3. And what becomes when we're contracting of addition? Addition becomes multiplication. We don't have it here, but we can remember, hopefully, that subtraction becomes division. And anyway, our goal here was to make this into one big fat logarithm. 3 to the second is 9, 2 to the third is 8, and I believe that we've done it.
What a dumb thing to do.
Well, hold on just a second, and I'll show you why you might want to make this into one big logarithm. Another thing that we learned regarding equations was to switch it into exponential form. Remember what the base is? Remember that the log is an exponent, so we could rewrite this using the old switcheroo as the base 4 to the exponent, that's what the logarithm is, to the exponent 2 equals the number or expression x minus 2. Well, 4 to the second is 16, and now we can solve the equation. Adding 2 to both sides, x in this case is 18.
I can do that, but I don't want to.
Now it's very important, hopefully you learned from the last homework, that you have to put it in and check it, because they don't always work. If we take our 18 and put it in, we'll take the log base 4 of 18 minus 2, or 16. Now, the log base 4 of 16, is that 2? Well, 4 to the 2 does equal 16, so it checks. But make sure you always check, because often some of these don't work. Now, using those two principles, the properties of logs to condense and the old switcheroo, let's look at a more advanced logarithm equation.
And now, ladies and gentlemen, let's get ready to rumble!
Now, we can't use the old switcheroo here, can we, until we only have one logarithm. So we're going to have to condense it into one logarithm, then we can use the old switcheroo. So let's do that. I condense addition into multiplication, and now I have one logarithm. Hopefully you see the need for that. And I can now change it using the old switcheroo. 2 to the 1th, the base of 2 and the exponent or logarithm of 1, equals the number or expression x times quantity x minus 1. Well, now I can solve it. 2 to the 1th is 2, and x squared minus x is going to turn this into a quadratic equation, which I can solve if I get a 0 on one side. I'll do that. This one is factorable. So the answers, there's 2, are going to be, well, what makes that 0? A positive 2. And what makes that 0 is a negative 1. So we have 2, I should say, possible answers, because
And you're going to do it because I said so.
we need to plug these in because we're not sure they work. Well, let's start with,
Could it be?
let's try putting in negative 1. Now, if you put in negative 1 for x, you come up against a wall right away because You have to ask yourself, remember the rules of logs.
There's something wrong with us. Something very, very wrong.
You can't take the log of a negative number. So that
Nothing for you.
has got to be out. Now let's try 2. He may be out as well.
Could it be?
If we put a 2 in for x, the log base 2 of 2, the log base 2 of 2 is what? Is 1. And the log base 2 of 1, what's the log of 1, no matter what base you use?
Oh, right, guys.
And son of a gun, the left side will be 1 plus 0, or 1, and the right side
You have chosen wisely.
is also 1, and this one works. So the one solution to this is 2. So remember to always plug in and check your answers.
Excellent.
Got the idea? Well, go try it. Do your condensing, then do your old switcheroo and solve those equations.